This is Kritika R, 20BCE1326, and I will be explaining about the Blowfish algorithm. I have written very few details over here and I will be writing more as I explain. So basically what Blowfish algorithm is that it is an encryption algorithm which is being performed on a plain text in order to convert the plain text into a ciphertext. So in order to go in depth into the algorithm, we have to understand a certain keywords. So the first and foremost keyword that is to be understood is the word encryption. So what exactly is encryption? So let us consider two people, person A and person B. And person A wants to send some kind of message to person B, and this message happens to be very confidential message. There are several ways through which A can achieve this. A can just send it to B, but by just sending it to B without performing any kind of encryption on it, A is making that particular confidential data vulnerable to a lot of attacks, like for example the man in the middle attack, which is and these kind of attacks are like very common, especially in an organizational scenario where a lot of data is being dealt with and a lot of confidential information has to be protected. So the basic definition of encryption is that it is the technique in which we will be performing on the plain text, so that any kind of third party or any kind of unauthorized person will not be able to decipher the plain text. So the next term that I will next few terms that I will be discussing are the two types of encryption algorithms. First is the symmetric encryption algorithm, and then comes the asymmetric encryption algorithm. So what is the symmetric encryption algorithm? So in case of symmetric encryption algorithm, we will be using only one key, meaning only one key will be used between the transfer message from A to B in order to encrypt it and decrypt it. In case of asymmetric cryptographic algorithms, we will be using two keys. One is the public key and the other is the private key. Each of the person associated with the transfer message will be having a set of these keys, a set of public key and a private key. So the Blowfish algorithm itself comes under symmetric cryptographic algorithm. So basically we will be using only one key in this algorithm. The next term that I have to discuss is the Feastel structure. The Feastel structure is the basic structure that is being used in a lot of symmetric cryptographic algorithms, and I have drawn the structure over here. So basically this block that you see over here is the plain text. In this algorithm, the plain text will be split into two. First, the left plain text and the right plain text. And then what happens is the left plain text will be we will be keeping it as is for now. For now, we will be performing operations on the right plain text. The right plain text will be inputted to a function f along with the subkey f. So what is a subkey? Subkey is basically the key that we use for one round of encryption in case of Feastel structure. So here I have mentioned K1. This subkey will be inputted to the function f as well along with the right plain text for the first round, and then the output from this function will be XORed with the left plain text that we got initially. This output from the XOR operation will be given as input as the right plain text to the next round. So what will be the left plain text for the next round? The left plain text will just be the will just be the value of the right plain text which was there in the previous round. So this concludes one whole round, and this operation happens for n different times. So basically so what exactly is n? How can we get the value of n? So n is the number of rounds for the fetal structure. So the value of this n is very important, because if in case we choose the value to be very less, then the algorithm itself will be very weak. The encryption can be easily broken down. So if that is the case, then we can just include as many rounds as we want, right? But we can't do that as well, because doing that will result in a situation where a lot of resources are being unnecessarily used. So in order to avoid that, we have to bring a balance between security and efficiency. Bring a balance between security and efficiency. This is called security efficiency trade-off. So now that we have performed the first round, the next round will also be performed in a similar manner but with a different subkey. So how are these subkeys being generated? For each and every algorithm, the process of generation of subkeys will be different. And for the Blowfish algorithm, I will be discussing it in a few minutes. So in the final round, as we can see here, this is Ln-1, as in the round before the input to the final round, and Rn-1, which is the right plain text for the final round. After performing the function and the XOR operation, the output, the Ln-1, the output XOR operation between the Ln-1 and the output from the function will be the right hand side part of the ciphertext, and the left hand side part of the ciphertext will be the value of R, whatever is in the Rn-1. So finally we get the ciphertext. This whole thing is the process of encryption. But how do we perform decryption? So the decryption is literally the same process, but instead of keeping the instead of using the plain text here, we will be using the ciphertext. Now that I have discussed about fetal structure, we can get more in depth with the Blowfish algorithm. Blowfish algorithm, which was created by Bruce Schneier, is an symmetric encryption algorithm. This algorithm has the following parameters. The block size is 64 bits. So what exactly is block size? I have not mentioned this before, but there is this term called block cipher, meaning that we will be splitting the given message into blocks of constant size. And for Blowfish algorithm, this size happens to be 64 bits. So that is what block size is. So Blowfish algorithm is a type of block cipher algorithm, and the block size is 64 bits, and then the number of rounds is 16. So what is number of rounds? So while discussing this fetal structure, I have also discussed about n, and this n is the number of rounds that we are performing, and it is 16 for this algorithm. And key size is from 32 to 448 bits. So usually in other algorithms we have a constant key size. So for example, in DES we have only key size of like 56 bits. 56 bits. And then in case of AES, there are three sizes. One is 128 and the other is 192, and then the other size happens to be 256 size. So these three sizes are the only sizes that are possible in AES. But in case Blowfish is a very different algorithm. We will be having sizes of any size between the length 32 to 448 bits. This size is for the key, and then the number of subkeys. So as I have mentioned before, these subkeys will be generated differently for each and every algorithm, and the number of subkeys that we should use for Blowfish algorithm is 18. Now we will get into the main part of the algorithm. So the steps involved in this algorithm, we will be basically performing 4 steps in this algorithm. I have written it partially. So first step is to generate the subkeys. So basically generation of subkeys is very important. We have key K, the key K, and this will be called as the initial key, and this key, using this key we will be generating the subkeys. These subkeys are called the P array in this because we will be having the 18 subkeys in an array named P. This array P will be of size 18, and each of the locations will be of size 32 bits. Now, how exactly do we generate the initial key? I mean, how exactly do we generate the subkey? So first we have key K. So first we have key K, and then the P array, which is from P of 0 to P of 17. From 0 to 17 the size is 18. So now initially the P array will be containing some values, and these values are constant, and while during the starting of the algorithm these values will always be constant, and the values are hexadecimal values of pi. So for example, the location in P of 0 will contain the 0th hexadecimal value of pi. So similarly the 17 initial values of P array will be there, but we will be performing certain operations on the P array to transform it into a different P array which is suitable for the particular message. So what we will be doing is, we have P of 0. So the operation we will be performing is XOR. So P of 0, we will be performing XOR with the first 32 bits of initial key. So basically the key can be from size 32 to 488, right? So we can like perform XOR with P of 0 and the first 32 bits of the initial key to get the final value for P of 0. This same thing will happen for all the 18 locations in the array. But there is a situation where the size of the array is like way much bigger than the size of the initial key. So like for example, let's say let's take the highest value that is possible, which is 448 bits. And if I like take 448 bits and divided it by the size that we are taking, which is 32, if we divide it, the final value will be 14. But we have 18 locations in the array. So what will we be assigning for the rest of the 4 locations? So for until 0 to 13, so that is 14 locations, we will be using all of the 448 bits as 32, 32, 32, and then when we reach P of 14, for that we will be assigning the we will be performing XOR. We will like let's say 32, so on up to the final 32. This for initially we will be performing XOR with P of 0, and then this is from length 0 to 448. Now finally this one will be performing XOR with the P of 13. Now the P of 14 we will be performing XOR with the first 32 bits. So first 32 bits we will be performing XOR, and then the next 32 bits we will be P of 14 over here, performing XOR with P of 15. So similarly we will be rotating, we will be going back, like if the locations gets filled, we will be going back to the first position, and then we will be performing XOR that way. And so this way we will be having 18 different values for the P array. Those are new values which were uniquely generated for the particular initial key. So now that we have generated the subkeys, we have generated all 18 of the subkeys. The next step is to initialize the S box. So what exactly is an S box? An S box also an S box, which is known as the substitution box, is basically performs the operation of substitution. So basically, let's say we give it an input of size m. It will transform it, it will give an output of size n. But the value of m and n may not be same. So basically, we will be substituting those m bits with some other n bits which is of probably lower size. So for the given algorithm, 256 entries will be there for the substitution boxes, and then we will be using 4 substitution boxes for the algorithm. These entries will each have 32 bits of size. In case of DES, the S boxes are like in most of the cases the same S box will be used. It's like it will look like a table. With the input value it is being given, it will search a particular location and then give the output that is in the particular location. Yeah. So now the next step is encryption. The encryption happens in the form of the fetal structure that I have clearly explained over here. I have just written the first round. I will be writing more as I explain. So the 64-bit plain text, as I have mentioned before, the block size is 64. So basically, the input that you will be giving to the algorithm will be of size 64 only. 64-bit plain text. It will be divided into the left plain text and the right plain text. So now I will use a different color. The 64-bit plain text will be divided into 2, which is the left plain text and the right plain text, which is the first step of the fetal structure. And then here we will be performing operations on the left plain text. So first we will be performing XOR with the first subkey. So what is the first subkey? As I have mentioned over here, P of 0. This P of 0 is the subkey for the first round. So here I have mentioned P1. So I will be using P1 for round 1 from now on. So the round 1 will have the subkey of P1 and it will be XORed with, we will be performing XOR with the left plain text. This like as I have mentioned, the 64-bit plain text will be divided into 2. So both of these will be of 32 bits. The left plain text is of 32 bits, and as you can see here, the subkey is also of 32 bits. So when we perform XOR between them, the output between them will be of 32 bits as well. So this 32-bit value will be passed to a function, and then this function will perform some operations and give a 32-bit value, which we will be performing XOR with the right plain text. And then this output that we get over here will be passed on to the next round as the left plain text for the next round. And then what will be the right plain text over here? It will be the output of the XOR operation between the subkey and the left plain text. So this way 16 rounds happen, as I have mentioned before. 16 rounds of encryption happens in the Blowfish algorithm. So L2 and R2 I have mentioned it for the second round. Now we will in the second round also, first we will be performing the XOR operation, and then we will be passing the output from the XOR operation to a function f, and then the output from the function f we will be performing XOR operation with R2. So similarly all of these operations will happen for like 16 rounds, and then the final output of every facial structure will be swapped this way, as you can see over here. But this swapping is not necessary for the Blowfish algorithm. So what we do is we then take the final this swapping is not necessary, so we then take the final output and then swap it again, so that the it is as if the swapping never happened. And then if you notice we have 18 locations for the array, but the facial structure has only 16 rounds. So we will be passing one subkey per round. If we pass one subkey per round, then after 16 round we will still be left with 2 more subkeys. So what will we be doing with the 2 subkeys? So what we will be doing is that let us say the final output from n rounds is this. We will be performing XOR operation between P17, which is the final location for the last subkey, and then for right plain text we will be performing XOR with the 16th location, 16th subkey, 17th subkey. So now we have used all of the 18 subkeys in 16 rounds of and we have done 16 rounds of encryption. So the final output will be concatenation of the left plain text and the right plain text output. So now that I have given an overall view, we can go more in depth. So what have we missed? We have missed the main thing, which is the function f. So what exactly happens in this function? In the previous step we have initialized the s boxes. So why have we initialized the s boxes? It is to perform operations in the function f. So this function f will have a 32-bit input, right? So what we do is we have 4 substitution boxes for Blowfish algorithm. So let's say S1, S2, S3 and S4, and we get a 32-bit input to this whole function. We will be splitting the 32 bits into 4, meaning we will be splitting the 32 bits into 8, 8, 8, 8. So 8 input, 8 input, 8 input, 8 input. So as I have mentioned before, substitution box will will substitute this 8 bits into something else. In this case, we will be substituting it into the 32 bits using its S boxes. So we get 32-bit output for each of these S boxes. And this does not end here. We will be performing some more operations on this to get the final output has to be of 32 bits in order to in order for us to be able to perform XOR with the right plain text. So what we do is we first perform AND operation. So we first perform AND operation. The AND operation is between the first two S boxes. Now now we will be performing XOR operation between the output from the first AND operation between the first two S boxes and the output from the third S box. So XOR operation, and then finally there is one more operation which is also a AND operation. So the output from the XOR operation will be, we will be performing AND operation between the output value from the fourth S box. So this will finally generate a 32-bit output which will be performing XOR with the right plain text. And we have to, one main fact that we have to note is that the AND operation over here is not just a simple AND operation. It is addition, I'm so sorry, I will be writing here. Addition modulo 2 to the power of 32. It is the addition modulo 2 to the power of 32. So now we finally get the 32-bit output which we will be performing XOR with over here, and then all these rounds will be performed. So while discussing about the steps involved, I mentioned that there are 4 steps. The fourth step is this particular step that I have mentioned here. This is the fourth step. So the final step is that we will be getting the final values of right and left plain text, and then we will be performing swapping it, and then we will be performing XOR operation between the 17th and the 18th subkey. So finally we get the cipher text, and then this cipher text, how exactly do we decrypt it? While discussing feature structure, I told you that the cipher text can just be plain text will just be replaced with cipher text, and then the whole operation is the same. And yes, that is what we will be doing here. We will be taking the cipher text and placing it over here. So finally we will be having 32 plus 32, which is 64-bit cipher text. We will be placing it here, we will be dividing it into 2, we will be performing XOR, we will be performing substitution, and then we perform XOR over here, and then do it all for 16 rounds. The main point to be noted over here is that the keys, the subkeys that are being used while encryption and the subkeys that are being used while decryption are the same. Now the whole encryption, Blowfish encryption algorithm is over. So to sum it up, to sum the whole thing up, the Blowfish algorithm is a symmetric encryption algorithm. It will be having one key. It uses blocks of 64 bits, size 64 bits. The number of rounds is 16, and then the key is of variable size, which is 32 to 448 bits, and then we will be using 4 substitution boxes to it. The number of subkeys will be 18. So first we will be generating the subkeys with the help of the initial key by performing XOR operation by dividing the original message into 32 bit blocks, and then performing XOR operation with the array locations, and then if it overflows we just go back to the first location to perform XOR, and then the next step is to initialize the S box, and then we come to the encryption where the 64 bits will be divided into 2, left and right, and then we will be performing certain XOR operations and substitution operations with the help of the substitution box, and then we get the final output of left and right plain text, which we will be swapping, and then we will be performing XOR with the 17th and the 18th subkey to get the ciphertext. So what exactly are the advantages of this algorithm? Why should I use this algorithm? This algorithm, I would say, is very secure. It is because of this 32 to 488 bits. It has variable key length, so it will be more secure. And then this algorithm uses piecewise structure, so it is also said to be fast and efficient, and that is why this Blowfish algorithm is being used. And initially it was also designed to be the replacement for the data encryption standard to overcome its shortcomings. Yes, so that is Blowfish algorithm. Thank you.